Today's lesson objective, you will solve systems of linear equations by graphing. So a solution to a system of two linear equations is an ordered pair that works in both equations. Okay? The solution is an ordered pair that satisfies both equations. And of course, the system is just two equations with two variables. So it can't work in just one of them. It has to work in both of them. Alright, so I've got the system 4x plus y equals 8 and 2x minus 3y equals 8. So I want to solve it by graphing. These are set up where I could actually graph with intercepts pretty easily. Or you can rearrange them and put them into y equals mx plus 3 form. But since everything's going to divide nice and pretty, I think I'm going to do intercepts. So when you graph with the intercepts, you can just make yourself a little xy table with two zeros. So if y is 0, what's x going to be in that top equation? Well, 4x is going to equal 8, so what is x going to have to be? 2. Alright, and now if I do the opposite and I say that x is 0, y is 8. So that first line is going to go from 2 on the x-axis up to 8 on the y-axis. And then I'll go ahead and extend it. Alright, and then I'll do the other one. Alright, so if y is 0, what's x going to be? 2x equals 18, right? So what's x? 9. And then if I do the opposite, okay, so that line, I'm going to go from 9 on the x-axis down to -6. Okay, so then where they are crossing should work in both equations. They're at 3, -4. But I'm going to check the solution algebraically to make sure it works in both of them. So I'm going to do 4 times 3 plus -4 equals 8. And I'm going to do 2 times 3 minus 3 times -4 equals 18. I'm going to make sure they both work. So here I get 12 minus 4 equals 8. That one works. And here I get 6 plus 12 equals 18. So that one works. So that means I did the graphing right. And so my answer is 3, -4. Okay? Any questions? Alright. So how about if you guys graph this one and find the solution of that? You can either rearrange it into y equals mx plus b, or, and yeah, you're probably going to want to do that at least for the second one, because it doesn't divide as pretty on that one. So. But you could do it with the intercepts, you just have fractions of them. Okay, so the first one works to use intercepts. If we use the intercepts, the x-intercept is 1, and the y-intercept is 8. That line there. And then the other one, you can do the intercepts, but it comes out of fractions. So I chose to do it in y equals mx plus b form. And that's my y-intercept, right? So I go to -8 to start, and then I have to go down 3 over 2, or I can go backwards. But at any rate, I already know it because right off the bat, that's where I started, right? So 0, -8 is the point. And then again, you should check it. 8 times 0 minus 8 equals -8. That works. And then 3 times 0 plus 2 times -8 equals -16, and that works. All right, so we can classify the systems depending on how many solutions there are. If there is exactly one solution, then that means that the lines intersect, right? And we would classify it as consistent and independent. Sometimes when you get a problem, it turns out that it's actually the same line. It's just a multiple of it. Whenever it's the same line, that means there's infinitely many solutions, right? And so that we classify as consistent and dependent. And then finally, if I have parallel lines, they never intersect, so there's no solution. So you're going to have a situation where you've got same slope, but you have different y-intercepts. And the way we classify that is inconsistent. Alright, so we're going to solve the system by graphing, and then we're going to classify it. So, since 3 doesn't go into 8 evenly, I'll go ahead and rearrange this one. So if I subtract the 4x, I get negative 3y equals negative 4x plus 8, and then I divide by the negative 3. I get that y equals 4/3 x minus 8/3. Isn't that a lovely number? Okay, so I go to a negative 8/3, which is 2 and 2/3, right? And I'm going to go up 4 over 3. 1, 2, 3, 4, 1, 3. Now if I rearrange the second equation, I take out or subtract 8x from both sides, I get negative 6y equals negative 8x plus 16. And if I reduce everything, what happens? It's the same line. It's just going to be right on top of this one. So when it's the same line, it's called consistent and dependent. Oh, well, first I should probably write there are infinitely many solutions. That's the solution. Infinitely many solutions. It is consistent and dependent. Questions? do another example for you. So this one will work with intercepts pretty easily. Or I could just rearrange it really easily also. The intercepts. Alright, so for the 2x plus y equals 4, I get that if y is 0, x is 2, and then x is 0, y is 4. So 2 equals 4. And for the other one, if y is 0, x is 1/2. And if x is 0, y is 1. So I'll say it's in 0.05. But if you rearrange it also, you can see it has the same slope. So what kind of lines do I have? Parallel lines. So that means that there is no solution. They are inconsistent. You guys do a few of these on whiteboards so you can practice all that fun graphing. Any questions? Alright, so there's your first one to graph and classify. Okay, so for the first equation, when you rearrange it, you get y equals 3 halves x minus 5. So to graph that line, you start at that point on the y-axis. That's your y-intercept. So I start at -5 on the y-axis, not the x-axis. My slope gives me my rise over my run. There's my slope right there at 3 halves. So that means I'm going to go up 3 over 2. Up 3 over 2. Okay, then rearrange the other one. Alright, so you should have gotten y equals 3 halves x minus 1 for the second one. Oops. So you start at -1 and you go up 3 over 1. So, is there a solution? No solution, and what is it? Inconsistent. Alright, let's see if you guys can do better on this one. Okay, so you end up with -1, 3. You're typing so many. To check the answers algebraically, you get -2 times -1 plus 3 equals 5. Gotta get 2 plus 3 equals 5. That one works.